Okay, so I will have those graded and put in the grade book before the end of 7th period today. All right, so just a couple things I need to remind you of before we finish up 2.1 with sequences. First up, we have the first of 4 AP prep sessions happening this Saturday, the 22nd, at Coronado High School from 9 a.m. to noon. It's going to be broke up into 2 sections. I'll be presenting for half of it. Another instructor will be doing the other half, but it's going to be over polynomial and rational functions, so a review over that material. So if you're able to show up, great. You don't have to stay the entire time. If you have to leave early or show up late, that's fine, as long as you're able to make it. How many people believe they'll be able to make it on Saturday? Okay, 1, 2. Okay, so 2. Okay, that's all right. That's all right. All right, thank you so much. And then the only other item, you want to be looking ahead to this on Thursday, the 27th of next week. That is our second exam. So I'll give you a 3x5 note card this coming Friday. You can write, bless you, whatever you want on it. It is going to cover lessons 111 to 2.1. So sequences, guaranteed there'll be at least one, bless you, problem on there from that. So maybe you want to put the formulas for arithmetic and geometric. I'll go ahead and tell you there's a binomial theorem problem on there. So maybe you want Pascal's triangle, or maybe you want to put combination, how you would find the location inside the triangle. I'll go ahead and tell you there's also a regression problem on there where you're given a table, you got to put that in the calculator, have it create the equation. So maybe it's the keystrokes, but whatever you want to put on that card to help you out is good to go. All right, so any questions about that? Okay, well, if you'll pull out the notes for 2.1, we're going to go ahead and wrap this up. And then tomorrow, I kind of see us coming in, passing back the quiz. We'll talk about it, and then begin 2.2. It is not going to take us long to do 2.2. I would imagine we'll be done by the end of this week. Excuse me. All right, so we're talking about sequences, which is an ordered list of numbers or other mathematical objects that follow a particular pattern. So we were looking at, firstly, arithmetic. Now, these are linear functions, but they're not continuous. In place of the slope, we have the common difference d. Our formula a sub n equals a sub k plus d times n minus k. So we went through several examples yesterday, and everybody seemed to be responding to those pretty well. And currently, we are on geometric sequences. So these are exponential functions, but they're not continuous. Okay, so they have what's known as a common ratio r. This is the base, okay, of your function. We're looking at g sub n equals g sub k times r to the n minus k. All right, so we're on the very last page here. So the top part of the reminder is basically just everything I already talked about. So let's get right to an example. Example 1, find an equation for the geometric sequence with g sub 3 equals negative 3. So remember, this little subscript, this is telling me the term number. So the third term is negative 3, and we have a common ratio r of 10. All they want me to do is write the function. But remember, this is what we're going to use. So g sub n is equal to, then we'll have g sub k times r to the n minus k. Remember, for these functions, whether it's arithmetic or geometric, you got to put the value of the term in there as well as the term number. Okay, so let's see what we got. I'm looking for the function, so g sub n equals. Well, the one thing we know for sure is that the r common ratio is 10. Remember, that's your base. Okay. Well, the only term I have is the third one, negative 3. So I'm going to put the value right in front, but then the power is always n minus k. So in this case, negative 3 is the third term, so it's going to be n minus 3. And there's my function. The nice thing about geometric, once you sub in, there's no simplifying. You got what you need. Okay. So any questions why I put things where I did? Okay, well, let's take this and try number 2. We got a geometric sequence. So this is telling me that the second term is 24 and the common ratio is 1/2. Okay, so let's go ahead and find an expression for G sub n. So we're going to do the same thing that we did on example 1. Remember, here's the standard form, G sub n equals G sub k times r to the n minus k. Okay, so by show of hands, who thinks they know what the function should look like? Okay, Harrison, what you got? What should I write down? Okay, we are super close. There's just one detail that's off. Okay, there we go. Because this k, it does represent the term number. So we already used the value of 24. That is absolutely right. But 24 is the second term. So we put the value in and we put the term number in. There we go. Perfect, perfect, perfect. Okay. Well, now that I got my function, we're wanting to find the fifth term. Okay. So that would just be subbing in this 5 right here. So it looks like we're going to have 24 times 1/2. Well, that's going to be to the third power. What's 1/2 to the third? 1/8. And what is 1/8 of 24? 3. So the fifth term would be 3. Okay. SJ. Anybody having a hard time? In fact, you'd probably go ahead and say those were pretty easy, right? Okay. Well, the reason those are so easy is because you're only dealing with one term, but more importantly, it gave you the common ratio. So what if we go ahead and start looking at problems that don't give you R, but give you two terms? Okay, so that's where this box comes in, these set of steps. So number 1, use both terms to create one equation in general form. Now use the larger k value term as the G sub n term. So this is just like we talked about yesterday. If you're given two terms, the larger term number, we're going to say that's n. The smaller term number, we're going to say that's k, just so we can identify which is which. Okay. Then step number 2, solve for r using that equation that we created. And then step number 3, use the value of r found in step 2, along with one of the terms, doesn't matter which one, to write the general form of the geometric sequence. Okay, so let's take a look at an example. So example 3, we've got a geometric sequence. So it says the third term is -2, and the sixth term is 128. So given two terms, remember we're trying to figure out which one is n, which one is k. So based on what we said yesterday in this table, the larger term number will be what? Okay, so in this case here, because we're dealing with the third and sixth terms, obviously the sixth is larger, so n is 6 in this case. So that means the smaller term number 3, that's going to be k. Okay, so now we've identified what we're looking at. Okay, so we're going to plug both of these into the term, the same function, at the same time. So G sub n is equal to G sub k times r to the n minus k. Now I'm going to go ahead and do today what I started off doing yesterday, where I plugged in the notation before I plugged in the value. Okay, so because I said that n was 6, G sub n, I'm going to start by saying G sub 6 equals G sub k, I'm going to plug in G sub 3. I have no idea what r is, okay, but the power, n minus k, I can say that's 6 minus 3. Is everybody okay why I placed things where I did? Okay. Well, now let's actually go ahead and plug in the values. Let me continue this up here. So the sixth term is 128 equals, okay, the third term was a -2 times r, and the 6 minus 3 would cube that. See, once I substitute in, well, now I've got myself an equation that I can solve for r. Is everybody okay? What would I do next? Got to divide by -2. There we go. So 128 over -2, that's a -64. Those are going to cancel, equals r cubed. So how am I going to get rid of that cubed? Cube root. And luckily for us, -64 is a perfect cube. Okay. So help me out. What is the cube root of a -64? What number times itself 3 times would give me 64. 4, so this one would be negative 4. Remember, when you have an odd index, an odd root, the answer is the sign is the same sign as your radicand. Okay. Now I know the value of r. I can choose either of those two terms, whether it's the third or the sixth. I can write my function. I can now go ahead and answer the question. Okay. Now, while we can go ahead and use either one, let me do this. Let me go ahead and take this off right here. Okay. I'm going to go ahead, because we're going to be plugging into the function here where it has k, I'm going to go ahead and use the term that we already labeled as k. That way we're not confusing anybody. We're just using the same values. Okay. So that means that I'm going to have g sub n equals, well, negative 2 times, we found r to be negative 4. But then my power is going to be n minus what? What term number is negative 2? Remember, it was the third, so it has to be n minus 3. Remember, you got to plug in the value of the term and the term number. There's my function. Now remember, even if you decided to go ahead and use the sixth term, it's going to look like a completely different function, but it still is going to give you the right answer. Okay. And in fact, what are we trying to find here? Yeah, we want to find the 11th term. So if I were to go ahead and plug that in, we're going to have g sub 11 equals negative 2 times negative 4 to the 8th power. Okay, so let's see what that would be. Let's come on over here to the calculator. Negative 2 times negative 4 to the 8th. Okay, so it's going to be a really small number, but who can help me out? What is it? No? Negative what? Okay. There we go. So negative 131,072. Perfect, perfect, perfect. So negative 131,072. So I've got not only my answer, but I got the function that gave me that answer. Okay. Questions? Oh, why is it so negative? Well, when you take a look, this portion right here, see, I'm raising a negative to an even power. So that's going to be a positive portion, but then I'm multiplying it by a negative. Let me see how you did it. Oh, I see what you did. So the calculator is programmed to follow the order of operations. So without the parentheses, it took the exponent and then multiplied by what it thought was a negative 1. So that's why that came out negative. Okay. All right. So here is our final problem. Okay. We've got the second term is 48. The seventh term is 1.5. Okay. So first, find me an expression for g sub n, just like we did previously, and then use that to find the 11th term. I'll go ahead and tell you the 11th term will be a fraction. Now, you got your calculator. You're allowed to work with decimals through the process, but make sure that your final answer will be a fraction. Okay. Now, the way I worked it, I didn't need to go ahead and use the calculator because I worked with the fractions. So whatever you prefer. So I'll give you a little bit of time to take a look at that, and then we will be done. Let's go back to view. And just so everybody's on the same page when we start, we got the second term, we got the seventh term. Which one's n? Is n 7 or 2? 7. Okay, remember the larger term, we're going to call that n. The smaller term, we're going to go ahead and call that k. 20. Okay, we're doing good. Excuse me 1 second. Sorry about that. That was my daughter. So her sectional, they're not doing them after school, so I can pick her up. All right, so let's see if everybody's on the right track. For your common ratio R, you should be getting 1/2. Does that look familiar? Okay. All right, so I'm going to go ahead and plug in. So because 7 is n, I'm going to start with 1.5 equals 48 times r to the n minus k, so that would be 7 minus 2. All right, so I'll just go ahead and erase that. That'll be to the 5th power. Then I need to divide by 48. And like I said, you're more than welcome to plug this in the calculator. I looked at it like this. 1.5 is 3/2. We're going to divide that by 48. Well, let's just pretend that's over 1. Let's multiply by the reciprocal. So 3/2 times 1 over 48. 3 and 48 will simplify. That's 1. That's 16. So what I end up with is 1/32. Okay, so 1 over 32 is equal to r to the 5th. And how do I get rid of that 5th? I have to take the what? 5th root. Okay, so the 5th root of 1 over 32, that's where I got the 1/2. Okay. And then just like before, you could use either term you want. It does not matter. I'm going to go ahead and use the second term because, again, that's what we already labeled as k. So here's what my formula looks like. G sub n is equal to 48 times 1/2, but that's going to be to the n minus 2 because 48 is the second term. Okay, looking good so far? Okay. Now we want to find the 11th term. So if I go ahead and plug 11 in there, show of hands, who thinks they got it? What's my fraction? Okay, let me rephrase. Who has a fraction? They're just not sure if it's right. Feel what you got. 3/32. That's a 3 right there. There we go. Perfect. And if I were to plug this in the calculator, this is going to be 48 times 1/2 to the 9th. So I could come over here, 48, and I'll just put 0.5 to the power of 9. So it's going to give me this decimal. Okay, like I said, you can work with the decimal if you wanted to. But I'm going to go to menu number. Let's approximate that fraction. Boom. There's my 3/32. Okay, how many people got that right? Nice, 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 nice. Okay, is there anything I can do? Questions? Okay, we are now done with the first lesson of Unit 2. We will talk about the homework on Friday. So that still gives us a couple of days. All right.